Welcome to our channel, where we explore fascinating historical events that shape the world we live in today. In this video, we're diving into the story of how London's sewage system was built and how it played a pivotal role in saving millions of lives. During the 19th century, London, like many rapidly growing cities, faced a terrifying public health crisis. Disease outbreaks, particularly cholera and typhus, were spreading like wildfire, claiming thousands of lives every year. The city's rapid urbanization, coupled with inadequate sanitation infrastructure, created a perfect storm for deadly diseases. But all of this began to change when a visionary engineer, Joseph Bazalgette, set out to solve this crisis. Today, we'll explore how his groundbreaking work in designing a modern sewage system not only transformed London's public health, but also revolutionized urban planning around the world. Before we get into the heart of the story, make sure to subscribe to our channel and like the video if you find this story interesting. Your support helps us bring more historical insights to life. And don't forget to comment below to let us know from which location you're watching this video. We'd love to hear from you. London, in the early 1800s, was a city teeming with life. But behind the hustle and bustle, an invisible crisis was brewing. The city's rapid growth, driven by the Industrial Revolution, brought millions of people into the capital, many of whom settled in overcrowded, unsanitary slums. At the time, sewage systems were rudimentary at best. The Thames River, which ran through the heart of the city, had long been used as a disposal site for waste, both human and industrial. Without proper sewage treatment, human waste would flow into the river, contaminating the water that thousands of Londoners relied on for drinking, cooking, and bathing. As a result, diseases like cholera, typhus, and dysentery spread quickly and frequently through the population. These diseases killed thousands, often in waves, and created a climate of fear and uncertainty. In the 1830s and 1840s, major cholera outbreaks devastated London, wiping out entire neighborhoods. The dead were buried in mass graves, and the public health system was overwhelmed. Yet there was no understanding of how diseases like cholera spread. Miasma theory, which suggested that diseases were caused by bad air or foul smells, was widely accepted at the time, and as a result, solutions to the public health crisis were based on ineffective measures, such as burning chemicals or using perfumes to mask the stench of the streets. The breakthrough came with the work of a few brave and determined individuals. John Snow, a doctor, was one of the first to propose that cholera was a waterborne disease. During the 1854 cholera outbreak, Snow mapped out the locations of the cholera cases and found that they were centered around a single water pump on Broad Street in Soho. He successfully argued that the disease was spread through contaminated water, not bad air, and advocated for the removal of the Broad Street pump handle, which stopped the outbreak in its tracks. This was one of the early signs that sanitation was key to controlling the spread of disease. But the city was far from ready to tackle the issue at a large scale. At the time, most of London's sewage systems consisted of simple open ditches that flowed directly into the river. These systems were woefully inadequate for a city that had expanded exponentially. The slums, where the poorest lived, were the hardest hit by disease, as people in these areas lived in overcrowded, poorly ventilated spaces with no access to clean water or sewage disposal. The sewage often collected in the streets, creating a breeding ground for bacteria and diseases. As cholera outbreaks continued to devastate London, the idea of improving the city's sanitation infrastructure gained more traction. The solution, however, was not easy, and the process of designing and building a comprehensive sewage system would take decades and involve overcoming significant political, financial, and engineering challenges. One man, Joseph Bazalgette, would eventually rise to the challenge and become the engineer responsible for transforming London's sanitation infrastructure. Bazalgette, who was working as a civil engineer for the city's Metropolitan Board of Works, was given the monumental task of designing a new sewage system for London. By the 1850s, the situation had become so dire that something had to be done. A public inquiry was held, and Bazalgette was appointed to lead the effort. He faced a daunting challenge. The city's population was growing rapidly, and the existing sewage infrastructure was completely inadequate. Not only did he need to design a system that could handle the current population, but he had to build one that would accommodate future growth, and withstand the challenges of industrialization. Bazalgette's solution was a system of underground sewers that would carry waste away from the city and deposit it into the Thames, downstream of the city. His design was bold and innovative. Instead of having the sewers flow into open ditches or the river at street level, he proposed a network of large underground pipes that would carry waste away from the heart of the city, where most of the population lived. Bazalgette's system was designed to handle an enormous amount of waste, and he built it with enough capacity to support London's growth for years to come. His design was nothing short of visionary. The system would consist of 82 miles of main sewers, with smaller pipes branching off to reach the city's neighborhoods. The pipes would be made of brick, carefully laid in a gradual slope to ensure that waste would flow by gravity, rather than requiring pumps. The system would also include intercepting sewers, which would divert waste from smaller rivers and streams into the main sewage network. To ensure that the system was effective, Bazalgette would also build a series of pump stations and sewage treatment plants to help purify the water before it was released into the Thames. Construction of the new system was an enormous undertaking. It required the labor of thousands of workers and took over a decade to complete. Despite facing significant obstacles, such as budget constraints, opposition from property owners, and the challenges of working in London's narrow, crowded streets, Bazalgette remained determined. His work, though initially met with skepticism, would later be hailed as one of the greatest engineering feats of the 19th century. The system was completed in 1875 and quickly proved to be a life-saving solution for London's public health crisis. As the new sewage system was completed, the impact was immediate and profound. The death rate from cholera and other waterborne diseases began to drop rapidly, and London's population started to see improvements in overall health and hygiene. Bazalgette's work laid the foundation for modern urban sanitation systems around the world. His design was the first large-scale sewage system to be built in an industrial city, and it provided a model for other cities to follow. The story of London's sewage system is a testament to the power of engineering and public health reform. Joseph Bazalgette's work saved millions of lives and helped transform London into one of the world's most important cities. His vision was not only about solving a public health crisis, but also about laying the groundwork for future urban development and sustainable city living. Today, we often take modern sewage systems for granted, but the impact of Bazalgette's work is still felt in cities worldwide, where the importance of clean water, waste management, and disease prevention continues to be at the forefront of urban planning. As we continue the journey through the incredible story of how London's sewage system was built and how it saved millions of lives, it's important to dive into the technical challenges Joseph Bazalgette faced during this monumental project. Bazalgette's design was nothing short of revolutionary, but the journey from concept to reality was filled with obstacles. The task of creating a modern sewage system for a rapidly growing, overcrowded city like London required not only brilliant engineering, but also an incredible amount of foresight, persistence, and innovation. At the time, London was a sprawling city with a population of over 2 million people, and it was growing rapidly due to the Industrial Revolution. The streets were narrow, the buildings were crammed together, and the infrastructure was outdated and insufficient for the city's booming population. Bazalgette's challenge was to create a sewage system that could handle an enormous increase in waste without disrupting the existing urban fabric. His vision involved designing underground tunnels that would divert the waste away from the crowded, disease-ridden areas of the city and safely transport it to treatment plants and disposal sites away from populated areas. One of the first challenges Bazalgette faced was the lack of space. London's streets, many of which were centuries old, were narrow and often overcrowded with buildings, markets, and other infrastructure. Digging tunnels large enough to accommodate the extensive network of sewers Bazalgette had in mind was no small feat. The team had to carefully plan the routes of the sewers, making sure that they avoided interfering with existing structures, public buildings, or other underground infrastructure like gas lines and water pipes. The system Bazalgette envisioned wasn't just about getting rid of waste. It had to be efficient, effective, and able to function for decades to come. This meant ensuring that the sewage system could handle both the present population and future growth. At the time, there was no way to predict exactly how much the population would grow or how industrialization would affect waste production. Bazalgette's foresight allowed him to design a system with an unprecedented capacity, ensuring that it could accommodate the future needs of a growing city. One of the biggest engineering challenges Bazalgette faced was how to move the waste through the system using only gravity. Unlike modern sewage systems that rely on pumps and other technologies to move waste, Bazalgette designed his system so that it could function by gravity alone. This was an innovative choice, as it meant that the system would be both energy efficient and able to function, even during times when mechanical systems might fail. To make this possible, Bazalgette had to ensure that the sewers would have a steady and consistent slope that would allow waste to flow smoothly without the need for pumps. Creating this sloping network was no easy task, as Bazalgette had to dig deep into London's soil to ensure the right angle for the pipes. In some areas, the sewer tunnels would have to run up to 30 feet underground to ensure the proper slope. This required the construction of enormous tunnels, some of which were wide enough to allow workers to walk through them. The process of digging these tunnels was grueling and dangerous, as workers had to contend with poor air quality, flooding, and the risk of cave-ins. Despite the challenges, Bazalgette's vision and leadership kept the project moving forward. Another key innovation in Bazalgette's design was his decision to use brick to line the sewers. While brick was a common building material, using it in such large quantities for underground tunnels was an unusual choice. Bazalgette opted for brick because of its durability and its ability to withstand the pressure of the soil and the weight of the city above. The brick lining also helped keep the sewers dry and prevented leaks, which was crucial in ensuring that waste would be carried efficiently through the system without spilling into the surrounding environment. In addition to the brick, Bazalgette had to ensure that the sewer tunnels were large enough to handle not just the wastewater from households, but also the industrial waste produced by the factories that were rapidly expanding throughout London. Factories and industrial businesses were a major source of pollution during the Industrial Revolution, and their waste had to be included in the sewage system. Bazalgette's design took this into account by creating larger sewer pipes in industrial areas and ensuring that these pipes could handle a higher volume of waste. While the engineering challenges were immense, Bazalgette also had to overcome significant political and financial hurdles. Many of London's political leaders were initially skeptical about Bazalgette's plans. The project was incredibly expensive, and there were concerns about the cost of building such an extensive infrastructure. Bazalgette had to convince both the government and the public that the long-term benefits of the sewage system would far outweigh the initial costs. Fortunately, a major cholera outbreak in 1854, which devastated parts of London, helped shift public opinion and political will in favor of improving sanitation. The government recognized that something had to be done to combat the rampant diseases that were taking so many lives. Even when the project was approved, Bazalgette still had to navigate budget constraints and political pressure. The cost of building the sewage system was significant, and Bazalgette had to carefully manage resources to ensure that the work was completed without running over budget. He was also working in a time of great political upheaval, and many local authorities had competing interests in how public funds should be spent. Bazalgette had to work tirelessly to push the project forward, despite facing opposition from many quarters. Despite these challenges, Bazalgette's leadership and innovation were unmatched. By the time the system was completed in the 1870s, it was clear that his work had transformed London. The new sewage system was a massive success, drastically reducing the spread of diseases like cholera, dysentery, and typhus. The death rate from these diseases began to drop dramatically, and London's public health improved significantly. Bazalgette's design not only solved the immediate public health crisis, but also laid the foundation for modern urban sanitation systems around the world. His work didn't just save lives in London, it served as a model for cities all over the world. The principles of sanitation, clean water, and disease prevention that Bazalgette championed were adopted by other rapidly growing cities, particularly in Europe and North America, which were facing similar challenges. Bazalgette's system also influenced the development of public health policies, and his innovations in sewage treatment and water management continue to be relevant today. Bazalgette's contribution to public health cannot be overstated. His vision, creativity, and determination in the face of immense challenges saved millions of lives in London and beyond. He didn't just solve a problem of urban sanitation. He laid the groundwork for the modern city. His work demonstrated the power of engineering to improve public health, and his legacy continues to shape the development of cities worldwide. As we move forward in our exploration of the monumental changes that Joseph Bazalgette brought to London's sanitation system, it's crucial to understand the lasting legacy of his work. The construction of London's sewage system didn't just improve public health in the Victorian era. It transformed urban living and became a model for modern infrastructure across the world. Bazalgette's vision and innovations revolutionized how cities around the globe would approach public health, sanitation, and urban planning. His design principles laid the groundwork for the clean, functional cities we know today. At the time, London was one of the largest and most rapidly growing cities in the world. The scale of the sewage system Bazalgette designed was unprecedented. His work in creating a vast underground network to handle the city's waste was one of the most ambitious engineering feats of the 19th century, and its success in curbing the spread of disease was immediate. By drastically reducing the death toll from cholera, typhus, and other waterborne diseases, Bazalgette's sewer system saved millions of lives, transforming London from a city constantly battling outbreaks to a city that could focus on growth and prosperity. Once the system was completed, the impact on London was nothing short of revolutionary. The death toll from cholera and other diseases dropped dramatically. Before Bazalgette's work, outbreaks of cholera would decimate entire neighborhoods, often killing hundreds or even thousands at a time. But after the completion of the sewer system, the rate of cholera deaths in London plummeted. This was not just because the waste was being carried away more efficiently, but also because the city's water sources were no longer contaminated with human waste. The success of Bazalgette's design didn't just stop in the 19th century. His sewer system became a foundation upon which future generations would build. Over time, as London continued to grow, the system was expanded, with additional sewers, interceptors, and treatment plants added to accommodate the needs of the increasing population. The design principles Bazalgette introduced were so effective that they were incorporated into new projects as cities across the globe began to modernize. As other cities grew and faced similar public health challenges, they looked to London as a model. Cities in Europe, North America, and even Asia adopted similar principles when building their own sewage systems. In the early 20th century, cities like New York, Paris, and Berlin all drew inspiration from London's infrastructure, creating their own underground sewage systems based on Bazalgette's successful design. His system was copied and adapted to fit the needs of these cities, with the same principles of gravity-fed waste removal and sewage treatment at the core of each new development. Bazalgette's influence extended beyond the development of sewers. His work played a key role in the development of modern urban planning. Before the advent of public health reforms, cities were growing haphazardly, with little regard for sanitation or the future needs of the population. But Bazalgette's work demonstrated the importance of long-term planning when it came to city infrastructure. The success of the sewage system in London showed that well-designed infrastructure could provide cities with the foundation for growth and health. Bazalgette's vision went beyond solving a temporary crisis. He created a system that would serve the city for over a century, enabling London to continue developing and adapting without having to deal with recurring health crises. The success of Bazalgette's work didn't just influence other cities. It became a model for how cities could evolve sustainably in the future. His emphasis on long-term infrastructure planning has influenced the way cities plan and build public health systems today. His work proved that investing in sanitation and public health infrastructure was not just about responding to immediate needs, but also about creating a lasting legacy that would benefit future generations. As cities across the world urbanized during the 20th century, the need for clean, efficient sewage systems became even more pressing. Urbanization brought more people into city centers, and with this increase in population came a significant increase in waste production. Industrialization, urban poverty, and the rise of slum dwellings put a tremendous strain on the health systems of cities around the world. The model Bazalgette, set with London's sewage system, became an essential part of global urban infrastructure, and it remains foundational to the planning of cities today. The development of modern wastewater treatment facilities and sanitation systems is directly linked to the principles Bazalgette pioneered. While the specifics of these systems have evolved with the advancement of technology, the basic concept of creating a network of underground pipes to carry waste away from population centers remains unchanged. The notion that clean water and waste management are fundamental to public health was driven home by Bazalgette's work, and today almost every modern city operates on the same foundational principles. Beyond engineering, Bazalgette's work had a profound effect on public health policy. Before his system, cities and governments had not fully grasped the link between sanitation and public health. The idea that disease prevention could be tied to waste management was a novel concept at the time, and Bazalgette's design demonstrated that public health could be improved through large-scale infrastructure projects. His work highlighted the importance of government investment in infrastructure and public health, laying the groundwork for future public health policies aimed at improving living conditions for urban populations. Governments around the world began to recognize the need for centralized infrastructure projects to address public health issues. As cities grew, they could no longer rely on small-scale local solutions to their sanitation problems. Bazalgette's work proved that citywide solutions, built on long-term planning and the implementation of comprehensive infrastructure, were the key to maintaining a healthy population. In the following decades, urban planning became more holistic, with a focus not only on housing and transportation, but also on ensuring that sanitation systems were integrated into the urban fabric. Fast forward to today, and Bazalgette's legacy is still evident in cities around the world. London's sewage system, though upgraded and modernized, remains largely based on the foundations Bazalgette laid in the 19th century. This system is still functioning at a high level, proving that his designs were not only effective in their time, but also capable of enduring the test of time. Moreover, Bazalgette's innovations continue to influence the development of modern sustainability practices. As cities face new challenges, such as climate change, population growth, and resource scarcity, the principles of efficient waste management, clean water access, and public health protection remain critical. Today's urban planners and engineers are building upon Bazalgette's foundation by integrating green technologies, waste-to-energy systems, and smart infrastructure that continue to prioritize both public health and environmental sustainability. Bazalgette's legacy extends to the way we approach global health crises today. His work showed that tackling disease prevention at a systemic level through comprehensive infrastructure is a critical component of public health strategy. The successes of modern sewage treatment, clean water initiatives, and disease management owe much to the vision Bazalgette had when he set out to improve the sanitation systems of Victorian London. As we move further into the 21st century, it's clear that Joseph Bazalgette's original sewage system, which was completed in the late 19th century, still plays a crucial role in the functioning of London's infrastructure. Though the system has undergone several upgrades and modernizations, the core of Bazalgette's design remains remarkably effective. His system, designed to manage the waste of a growing population and improve public health, continues to function as one of the world's most important examples of urban sanitation engineering. However, as London's population continues to grow and as new challenges emerge, the city must adapt and modernize its sanitation infrastructure. The initial challenge that Bazalgette faced, designing a system that could accommodate both the current needs of London and future growth, is still relevant today. The city now faces not only an increase in population, but also new threats like climate change, pollution, and the rise of emerging contaminants in water. In response, London's sewage system is undergoing significant transformations that build on Bazalgette's original work, while incorporating modern technologies. In recent years, the Thames Tideway Tunnel, a massive project aimed at addressing London's growing population and improving water quality in the River Thames, has been undertaken. This project is sometimes referred to as the Super Sewer because of its scale and importance. Like Bazalgette's work, The Thames Tideway Tunnel is a long-term solution to the problem of wastewater management. The new tunnel will collect and store sewage that would otherwise overflow into the river during periods of heavy rain, ensuring that untreated waste does not enter the Thames and contaminate the water supply. This is critical for maintaining the health of the city's residents and for protecting one of London's most iconic landmarks, the River Thames. The new sewage tunnel will be one of the largest infrastructure projects in London's history and will take years to complete. It is designed to handle an increase in population, accommodate climate change impacts, and address the growing concerns of water quality and pollution control. The Thames Tideway Tunnel is expected to be operational by the mid-2020s, and its completion will represent a massive leap forward in addressing the challenges Bazalgette's system was not designed to handle. Bazalgette's system, though still functional, was designed for a population of fewer than 2 million people, and now London's population has surpassed 8 million. The demands on sanitation infrastructure have grown exponentially, and the older parts of the sewage system are reaching their capacity limits. The new projects, like the Thames Tideway Tunnel, are an example of how cities must adapt and modernize their infrastructure to keep up with both population growth and changing environmental factors. This is not just about expanding the system, but also about using innovative technologies to ensure that the challenges of the future can be met. At the same time, climate change is presenting a new set of challenges for cities worldwide. The increasing frequency of extreme weather events, such as heavy rainfall and flooding, is putting significant pressure on sewage systems everywhere. For example, storm surges and intense rainfall events can overwhelm traditional sewage systems, causing untreated waste to spill into rivers and the sea. Bazalgette's system was not built to handle the increased pressures brought on by these new weather patterns. As a result, cities like London are looking to build more resilient systems that can adapt to these challenges. Modern innovations in water management are playing a crucial role in this transformation. Technologies such as smart sewage systems, real-time monitoring of water quality, and data-driven management are helping to better manage the flow of waste and prevent overflows during heavy rainfall. For instance, smart sensors placed throughout the sewage system can detect when the pipes are becoming overloaded and trigger alarms that allow authorities to take action before sewage spills into the environment. This kind of real-time monitoring and management helps prevent the spread of waterborne diseases and ensures the public's health remains protected. In addition to these technological advancements, sustainability has become a critical factor in the design and management of modern sewage systems. Bazalgette's system, while effective in the 19th century, did not account for the modern need for resource recovery. Today, cities are focused not only on removing waste, but also on finding ways to reuse and recycle waste products. Wastewater treatment plants now use advanced processes to capture biogas from sewage, which can be converted into renewable energy. The goal is not only to manage waste, but also to turn it into a resource that can power the city's infrastructure. Similarly, nutrient recovery systems are being implemented to capture valuable elements like phosphorus and nitrogen from wastewater, which can be used in fertilizer production. This new approach, called circular economy, aims to make sewage management part of a sustainable and self-sufficient system that minimizes waste. Another important aspect of modern sewage system upgrades is the integration of green infrastructure. Cities are increasingly looking to nature-based solutions to manage wastewater and stormwater. For example, green roofs, rain gardens, and permeable pavements are being used to reduce the amount of water that enters the sewage system during heavy rainfall. These solutions help prevent flooding and overflows by capturing and slowing the flow of rainwater before it reaches the drains. In some areas of London, these methods are being incorporated into urban design to complement the traditional sewage system and help the city adapt to a changing climate. Despite the success of these innovations, London's sewage system is still facing significant challenges, particularly in older areas of the city where the infrastructure is aging. The original brick-lined sewers, designed by Bazalgette, were built to last, but they were not intended to carry the volume of waste that modern London produces. As a result, parts of the system are reaching their capacity and require significant maintenance and upgrading. Over the past few decades, parts of the sewer system have been retrofitted with new materials, such as concrete and steel, to improve their longevity and capacity. To address these ongoing challenges, London's Thames Water and other local utilities are working on long-term plans to improve the efficiency of the sewage system. In addition to the construction of the Thames Tideway Tunnel, smaller-scale projects are being undertaken to upgrade the main sewerage network and improve wastewater treatment plants. These projects will help ensure that London's sewage system remains sustainable and effective in the years to come. Bazalgette's legacy is not just about sewage and sanitation. It's about modern urban living and the recognition that a city's infrastructure must be designed with both the current population and the future in mind. His work demonstrated that urban planning is not just about responding to immediate needs, but also about anticipating future growth and creating systems that can evolve over time. The challenges that Bazalgette faced in designing and building London's sewage system may have been immense, but his vision has continued to guide urban development in the city and around the world. As we continue exploring the incredible legacy of Joseph Bazalgette and the impact of his sewage system on London and the world, it's essential to understand how modern cities are addressing the challenges of climate change, sustainability, and resilient infrastructure. Bazalgette's work in the 19th century was visionary, not only in terms of improving public health, but also in providing a blueprint for how cities should plan for long-term growth. Today, as urban centers around the world face new environmental and demographic pressures, Bazalgette's pioneering approach to infrastructure design remains a model for modern cities, particularly in the fight against climate change. The global conversation on climate change has brought to light the urgent need for cities to adapt to rising sea levels, extreme weather events, and shifting environmental patterns. In London, the city that saw such devastating consequences from cholera outbreaks and inadequate sanitation in the past, the modern challenge is equally daunting: how to design resilient infrastructure that can withstand the increasing threat of climate change. And it's here that the design principles Bazalgette introduced nearly 150 years ago are still relevant. His vision for long-term sustainable infrastructure that prioritized public health, waste management, and future-proofing continues to be echoed in today's approaches to urban planning. Bazalgette's approach was grounded in the understanding that infrastructure was not just about solving problems in the present moment, but about creating systems that would serve future generations. His work on the sewage system anticipated the needs of a growing city, and now, with the challenges presented by climate change, urban planners and engineers are looking at how to create systems that will be resilient to environmental stress for decades to come. As more cities experience rapid urbanization, flooding, and pollution, the need for a sustainable sewage system has never been more urgent. In London, modern engineers and urban planners have started to build on the legacy of Bazalgette's design to ensure that the city can handle both population growth and climate-related challenges. One of the most significant challenges facing London today is the growing threat of flooding caused by rising sea levels and increased rainfall. As the climate continues to warm, London, like many coastal cities, is at risk of more frequent flooding due to storm surges and heavy rainfall. This is particularly true in areas near the Thames River, where Bazalgette's original sewage system was designed to carry waste away from the city and into the river. But in the face of climate change, the old design is no longer sufficient. The city is now focusing on how to adapt its infrastructure to address these threats. One of the key strategies is improving the Thames Barrier, an engineering marvel that helps protect London from flooding caused by tidal surges. Originally completed in the 1980s, the Thames Barrier is now being upgraded to handle the increased risks posed by climate change. It's an essential component of climate resilience for the city, ensuring that floodwaters do not breach the Thames banks and overwhelm the city's infrastructure. The barrier works in tandem with the Thames Tideway Tunnel, which will help divert excess sewage and stormwater from the river during periods of heavy rainfall, preventing contamination and reducing the risk of waterborne diseases, an issue London faced centuries ago before Bazalgette's work. Beyond flood prevention, modern approaches to sewage and waste management are emphasizing sustainability and resource recovery. For example, the idea of closing the loop in sewage management is gaining traction. Bazalgette's original system, while groundbreaking, was designed primarily to remove waste from urban areas and deposit it into the Thames. Today, cities are focused not just on moving waste, but also on extracting valuable resources from that waste. This approach is part of a broader movement towards a circular economy, where materials, water, and nutrients are recycled and reused rather than discarded. In the 21st century, one of the most pressing issues is energy consumption, particularly when it comes to the treatment and disposal of sewage. Modern sewage treatment plants are being designed with energy recovery in mind. For example, biogas produced from wastewater treatment processes can be captured and used as a renewable energy source. This approach not only reduces reliance on fossil fuels, but also reduces the carbon footprint of sewage treatment plants. London's wastewater treatment plants are working to become energy positive, meaning that they generate more energy than they consume, thanks to advances in biogas production and waste-to-energy technologies. Another important aspect of sustainable sewage systems in today's cities is the integration of green infrastructure into urban planning. Green infrastructure solutions, such as rain gardens, green roofs, and permeable pavement, are being used to capture rainwater and reduce the pressure on traditional sewage systems during storms. These solutions help manage the stormwater runoff that often overwhelms conventional sewage systems, leading to overflows and flooding. By incorporating green infrastructure into the urban fabric, cities can reduce the risk of flooding, improve water quality, and create more sustainable urban environments. This is an example of how modern cities are adapting Bazalgette's principles of wastewater management while addressing the challenges of climate change. One of the most important innovations in this area is the development of smart sewage systems. These systems use real-time data, sensors, and AI to monitor the flow of waste and water through the system, providing detailed insights into how the system is performing. This technology allows cities to better manage wastewater flows during heavy rainfall, identify blockages or leaks, and improve the overall efficiency of the sewage system. It also helps city planners predict when and where infrastructure upgrades may be needed to keep pace with population growth and climate risks. Smart technology has the potential to make sewage systems more responsive, efficient, and sustainable by providing better data and increasing resource efficiency. As cities around the world confront the challenges of climate change, sustainable waste management, and urbanization, the legacy of Bazalgette's sewage system remains an invaluable reference. His approach to designing a system that could handle the waste of a growing population has been adapted to meet the needs of modern cities. Today, the integration of green technologies, smart systems, and energy recovery is helping to make sewage management not only more sustainable, but also more resilient to the environmental challenges of the future. Bazalgette's work didn't just save millions of lives in the 19th century. It continues to influence the global fight against climate change and public health crises today. The principles he introduced, such as long-term planning, public health integration, and future-proofing, are just as relevant now as they were when London was first grappling with cholera outbreaks. Bazalgette's system was a foundational piece of urban infrastructure that demonstrated the power of engineering to solve some of the world's most pressing health problems, and today's cities are continuing to build upon that legacy to create a healthier, more sustainable future. As we continue to delve into the monumental impact of Joseph Bazalgette's sewage system, it's essential to explore the influence this project had beyond the boundaries of Victorian London. Bazalgette's visionary work not only transformed the public health landscape of his city, but also set a precedent for sanitation policies and public health strategies that would influence urban planning around the world. His work was foundational in establishing the crucial link between sanitation and public health, showing how well-designed infrastructure could be a powerful tool in preventing disease and improving overall quality of life. Before Bazalgette's sewage system, the prevailing thought was that disease was caused by bad air, the miasma theory, and cities around the world were dealing with outbreaks of cholera, typhus, and other waterborne diseases without truly understanding their root causes. The design of London's new sewer system was one of the first major steps in recognizing that sanitation, specifically the proper disposal of human waste and the management of water quality, was essential to combating these public health crises. Bazalgette's system directly responded to this need, improving the public's health by safely removing waste and reducing the contamination of drinking water. The influence of London's sewage system spread quickly across Europe and North America. After the success of Bazalgette's project, it became clear to other cities that modern urban development needed a comprehensive sanitation plan. The powerful impact of sanitation infrastructure in preventing disease led many countries to adopt similar strategies, and these systems would evolve over time to meet the changing demands of growing populations and urbanization. One of the most notable examples of Bazalgette's influence was seen in Paris, as London's cholera outbreaks decreased due to Bazalgette's system. Paris also faced the same growing health challenges brought on by rapid industrialization. In 1856, a French engineer, Georges-Eugène Haussmann, began the monumental project of transforming Paris into a modern, more sanitary city, and public health infrastructure was a major priority. He drew inspiration from the success of London's sewage system and began designing and constructing a similar system for Paris, albeit with modifications to fit the specific needs of the city. Haussmann's work in modernizing Paris laid the groundwork for the French capital's evolution into a cleaner, healthier city. In New York City, the rapid urbanization that took place in the late 19th century presented a host of public health challenges similar to those London faced. By the 1860s, cholera had become a serious concern for the city, and there was an urgent need for a modern sewage system. Influenced by the success of Bazalgette's work in London, the Board of Health in New York City began to push for the construction of a modern sewage network. The Croton Aqueduct, completed in the 1840s, had already provided New York with a reliable, clean water supply, but it was Bazalgette's system that offered a comprehensive solution for the city's growing waste management needs. The New York sewer system, completed in parts throughout the 19th century, was based on many of the same principles as Bazalgette's system. These new sewers were designed to channel waste away from the city's growing population and ensure that waste didn't contaminate the water supply. Much like London's system, New York's was designed to accommodate future growth, taking into account the rapid expansion of both the population and the industrial areas along the city's waterfront. Similar public health reforms were also adopted in Berlin, Toronto, and other cities around the world. Each of these cities, grappling with rapid urbanization, growing populations, and outbreaks of disease, saw the need for infrastructure systems that could manage the growing waste and protect public health. London's sewage system became a model for urban centers looking to modernize, and the fundamental lessons learned from Bazalgette's work have been applied universally in the decades that followed. Bazalgette's impact went beyond just the construction of sewage systems. His work directly contributed to the emerging field of public health as a whole. In the 19th century, public health was primarily concerned with disease management, responding to outbreaks of cholera, typhus, and other epidemics as they arose. However, Bazalgette's sewage system highlighted the importance of disease prevention through sanitation. This shift from reactive public health strategies to proactive disease prevention laid the groundwork for the public health movement in the 20th century. The emergence of sanitary engineering as a distinct discipline in the field of public health can be directly traced to Bazalgette's work. His innovative use of gravity in sewage systems, his foresight in planning for future growth, and his ability to recognize the fundamental link between clean water, waste removal, and disease prevention were groundbreaking contributions to both the engineering and public health fields. Bazalgette's success showed the world that modern sanitation infrastructure was not just an engineering necessity, it was a key public health intervention. In the 20th century, the World Health Organization, WHO, and other global health organizations built upon these early efforts. The WHO recognized the importance of clean water and sanitation in preventing diseases like cholera, typhoid, and dysentery, and it made sanitation a priority in its global health campaigns. The global sanitation movement has focused on ensuring that cities around the world build the infrastructure needed to provide clean water and proper waste disposal for all citizens, especially in developing nations. In developing countries, the legacy of Bazalgette's system has been crucial in the fight against waterborne diseases. Many of the challenges faced by cities in Africa, Asia, and Latin America in the 20th and 21st centuries mirror the conditions Bazalgette addressed in Victorian London: rapid urban growth, lack of sanitation infrastructure, and vulnerability to disease outbreaks. In these regions, international organizations and governments have worked to expand sewage systems and improve water quality, based on the principles established by Bazalgette. The lessons learned from Bazalgette's work continue to inform the development of modern sanitation systems today. Urbanization around the world has led to a new set of public health challenges, but Bazalgette's model of a comprehensive sewage system, one that is planned with the future in mind and is designed to handle growing populations, remains essential. Cities like Shanghai, Mumbai, and Sao Paulo are looking to modernize their own sanitation infrastructures by drawing inspiration from the innovative work of Joseph Bazalgette. Bazalgette's system also laid the groundwork for the development of modern environmental protection policies. As the world continues to address issues like pollution, climate change, and water scarcity, the principles of sustainable waste management and resource recovery that Bazalgette pioneered remain key to creating environmentally friendly cities. His work demonstrated that managing waste could be done in a way that benefited both public health and the environment, and this approach continues to shape policies that promote the circular economy. Joseph Bazalgette's contribution to urban planning and public health is far-reaching. His sewage system not only saved millions of lives in London, but also became the foundation for global sanitation policy. His system's success in controlling waterborne diseases has been mirrored around the world, and the core principles he introduced, sanitation infrastructure, long-term planning, resilience, and public health protection, remain central to the way modern cities approach infrastructure development. As we continue to explore the incredible legacy of Joseph Bazalgette's sewage system and its ongoing impact on modern sanitation practices, it's important to recognize how new technologies and innovations in environmental engineering are shaping the future of wastewater treatment and sanitation globally. While Bazalgette's design set the foundation for effective waste removal, the rapid urbanization and environmental challenges of the 21st century have brought forth a need for even more advanced, sustainable solutions in cities worldwide. The world is facing new and more complex challenges than ever before. Climate change, increasing urban populations, and growing environmental concerns are pressing issues that demand cutting-edge solutions. Today, cities are not only tasked with managing waste and preventing disease, they also must prioritize sustainability, resource conservation, and environmental protection. Modern wastewater treatment technologies are essential to meeting these challenges, and they are increasingly at the forefront of efforts to create resilient cities. One of the biggest innovations in modern wastewater treatment is the move toward resource recovery from sewage. In the past, sewage treatment focused primarily on removing contaminants and returning clean water to the environment. Today, cities around the world are adopting a more holistic approach, aiming to recover valuable resources from wastewater. These resources include energy, nutrients, and water, all of which can be reused or repurposed for other uses. This concept is known as the circular economy, and it represents a major shift in how cities think about sewage management. Modern wastewater treatment plants are now equipped with advanced technologies that can capture biogas from the breakdown of organic materials in sewage. This biogas can be converted into renewable energy, helping to power the treatment plants themselves or be fed back into the grid to provide electricity to the city. By recovering energy from wastewater, cities can reduce their reliance on fossil fuels and move toward more sustainable energy sources. Another significant innovation is the recovery of nutrients, such as nitrogen and phosphorus, from wastewater. These nutrients are essential for agriculture, and recovering them from wastewater can help reduce the need for chemical fertilizers, which are often produced using environmentally harmful processes. Modern nutrient recovery systems extract these valuable elements from sewage and repurpose them as fertilizers, helping to close the loop in wastewater management by turning waste into useful products. In some cities, these recovered nutrients are even being used in urban agriculture projects, contributing to local food production and sustainability. One of the most exciting developments in wastewater treatment is the rise of advanced filtration systems and membrane technologies. These systems use membranes to filter out contaminants at a molecular level, allowing for the production of recycled water that is so clean it can be used for drinking, irrigation, or industrial processes. In Singapore, for example, the NE Water program uses advanced filtration and reverse osmosis technologies to recycle wastewater into high-quality drinking water. This innovative approach has turned water scarcity into a non-issue for the city-state, and it's becoming an increasingly important model for water-scarce cities around the world. Meanwhile, smart technologies are transforming how wastewater treatment plants operate. With the advent of Internet of Things, IoT devices, real-time monitoring, and data analytics, cities can now track and manage wastewater flows more efficiently than ever before. Sensors placed throughout the sewage system provide continuous feedback on water quality, flow rates, and the condition of infrastructure. These sensors can detect leaks, blockages, or overflows, allowing for quicker responses and reducing the likelihood of sewage backups or contamination events. Moreover, these systems allow cities to collect massive amounts of data that can be used to optimize treatment processes, reduce costs, and improve overall system performance. By using big data, AI, and predictive analytics, modern sewage systems are becoming more responsive and adaptable. For example, AI-powered systems can predict when a sewage treatment plant will be operating at capacity based on weather patterns, population shifts, or other factors. This allows for proactive measures to prevent overflows or system failures before they occur, ensuring that waste is processed efficiently and safely. One key innovation in the field of wastewater treatment is the development of natural treatment systems that mimic the processes of the natural environment. Constructed wetlands, vegetated swales, and biofilters are becoming increasingly popular in urban areas as sustainable alternatives to traditional sewage treatment methods. These systems use natural processes, such as plant uptake and microbial action, to remove contaminants from wastewater. These green infrastructure solutions not only treat sewage, but also provide additional benefits, such as stormwater management, improved air quality, and the creation of habitats for wildlife. In New York City, the Department of Environmental Protection has introduced the concept of green infrastructure to complement its traditional sewage system. The city has built a network of green roofs, rain gardens, and permeable pavements that absorb rainwater and prevent it from overwhelming the city's sewer system. By using these green technologies, New York is reducing the risk of combined sewer overflows, CSOs, which occur when heavy rainfall causes raw sewage to spill into rivers and waterways. Green infrastructure also helps to filter pollutants from stormwater before it enters the sewer system, improving the quality of water entering treatment plants. Another significant advancement in modern wastewater treatment is the use of decentralized treatment systems. While traditional sewage systems rely on large, central treatment plants, decentralized systems treat wastewater at the source, often in smaller, localized treatment facilities. This approach is particularly useful in rural areas, remote locations, and smaller urban centers, where building and maintaining large infrastructure systems is not feasible. Decentralized systems can reduce costs, improve water quality, and help preserve local water sources by preventing contamination. In developing countries, decentralized and low-cost sanitation technologies are helping to address the lack of basic sanitation infrastructure. The Sanity, a portable sanitation system designed for use in areas without sewage networks, is one example of a low-tech solution to the sanitation crisis. These innovative solutions are helping to improve public health and water quality in places where conventional sewage systems are not yet a reality. The challenges of climate change, including more frequent extreme weather events, rising sea levels, and water scarcity, have made it clear that traditional approaches to wastewater management must evolve. In cities like Venice, Miami, and New Orleans, which are threatened by rising sea levels, there is an increasing need for resilient infrastructure that can adapt to changing environmental conditions. These cities are investing in adaptive strategies for wastewater treatment, including the construction of flood-resistant sewage systems and the development of coastal protections to prevent sewage systems from being overwhelmed by rising tides. In London, the Thames Tideway Tunnel is an example of such an adaptive strategy. The tunnel, which is currently under construction, will provide the city with additional sewage capacity, ensuring that future generations of Londoners will have access to the same level of public health protection that Bazalgette's system provided in the 19th century. It is designed to handle the increasing risks of heavy rainfall and flooding caused by climate change, while also ensuring that wastewater is treated efficiently and safely. The Thames Tideway Tunnel represents the latest innovation in a long line of infrastructure projects that have been built on Bazalgette's principles of long-term planning, public health, and resilience. As cities continue to grow and face the pressures of climate change, modern wastewater treatment technologies and green infrastructure solutions are playing a critical role in building sustainable, resilient urban environments. While Bazalgette's original sewage system laid the foundation for public health in London, the new technologies being developed today are taking his legacy a step further, ensuring that the city remains adaptable to future challenges. By embracing smart technologies, circular economy principles, and innovative wastewater treatment solutions, cities around the world are continuing to build on the legacy of Joseph Bazalgette to create more sustainable and healthy environments for generations to come. As we come to the final part of our journey through the story of Joseph Bazalgette's legacy, it's crucial to look ahead and understand how the future of global sanitation systems will evolve. The groundwork laid by Bazalgette in the 19th century, creating a sewage system that protected public health, improved living conditions, and allowed for the growth of London, continues to influence urban planning today. However, as cities around the world face increasing populations, climate change, and growing pollution, the challenge is now about building sanitation systems that are not only effective, but also resilient, sustainable, and innovative. In the 21st century, the global sanitation crisis remains a critical issue, especially in developing countries, where basic sanitation infrastructure is often lacking or insufficient. 2 billion people live without safely managed sanitation services, and more than 2 billion people still rely on contaminated water sources. Without access to proper sanitation, people are at risk of waterborne diseases, including cholera, dysentery, and hepatitis, which continue to claim lives in many parts of the world. The challenge is not just to replicate what was done in London in the 19th century, but to design solutions that are more adaptable, cost-effective, and appropriate for the challenges of today. The good news is that we're now seeing a new wave of technological innovations and creative solutions that are pushing the boundaries of wastewater management. These innovations are not just focused on dealing with waste, but also on recovering valuable resources, protecting water quality, and creating a circular economy where waste is no longer wasted. One of the most exciting innovations in wastewater treatment is the growing use of biological systems and natural treatments. Constructed wetlands and biofilters are increasingly used in both urban and rural settings to treat wastewater without relying on complex, energy-intensive machinery. These natural treatment systems use the power of plants, microorganisms, and soil to remove contaminants from water. In addition to treating wastewater, these systems offer numerous environmental benefits, including carbon sequestration, habitat creation for wildlife, and aesthetic value in urban areas. For instance, the city of Melbourne has incorporated constructed wetlands into its urban landscape, using them to treat wastewater and stormwater runoff. This approach is highly sustainable and cost-effective, as it reduces reliance on energy-intensive pumps and filtration systems. Similarly, the Greenway wastewater treatment plant in San Diego, California, uses a natural filtration system in combination with advanced membrane technologies to purify water and make it safe for reuse. These types of systems are perfect for cities that are facing water scarcity, as they reduce the strain on freshwater resources and provide high-quality recycled water. In developing countries, there is a push toward low-cost, decentralized sanitation solutions. These systems focus on treating wastewater at the point of generation, using simple and affordable technologies that don't require large-scale infrastructure. One of the most promising technologies in this space is the biotoilet. Biotoilets use biological processes to break down waste without water, eliminating the need for sewage pipes and water treatment plants. These toilets are being deployed in rural areas, refugee camps, and informal settlements to provide safe sanitation where conventional systems are not available. Another groundbreaking development is the use of waste-to-energy technologies. As the world grapples with climate change and the need for renewable energy, the energy potential within wastewater is being recognized. Biogas, produced during the breakdown of organic matter in sewage, can be captured and converted into renewable energy. Many modern wastewater treatment plants are now equipped with digesters that produce methane gas from sewage sludge, which is then used to generate electricity. This process not only helps reduce the carbon footprint of treatment plants, but also provides a sustainable energy source that can be used to power the plants themselves or be fed into the grid. For example, in Sweden, the Högbytorp wastewater treatment plant produces biogas from the treatment of organic waste, providing enough energy to power the plant and even feed excess energy back into the national grid. This approach is becoming increasingly important in a world that needs to balance waste management, energy production, and environmental sustainability. Another exciting development in the future of sanitation is the integration of smart technologies into sewage systems. Cities around the world are turning to smart sensors, real-time data, and AI-driven systems to improve the efficiency of their sewage infrastructure. These smart systems can monitor wastewater flows, detect blockages and leaks, and even predict when a sewage system will reach capacity. By gathering data in real time, cities can respond proactively to prevent overflows, ensure optimal performance, and avoid expensive and damaging failures. For instance, in Singapore, the Public Utilities Board, has implemented a smart water grid that includes advanced sensors throughout the sewage system. This system allows them to monitor water quality, detect leaks, and ensure that the system runs efficiently. Similarly, Tokyo has developed a smart sewage management system that integrates data analytics and real-time monitoring to prevent flooding and optimize sewage flow during heavy rains. Climate change is a major concern for cities, and the increasing frequency of extreme weather events and flooding poses a serious threat to existing infrastructure. To address these challenges, green infrastructure is becoming a key component of modern urban sanitation systems. Green roofs, permeable pavements, rain gardens, and urban wetlands are being used to manage stormwater runoff and reduce the burden on sewage systems during periods of heavy rainfall. These solutions, which absorb and filter rainwater, are a natural complement to traditional sewage systems and help cities become more resilient to the impacts of climate change. In New York City, the Green Infrastructure Program aims to reduce the amount of stormwater that flows into the city's combined sewer system by installing green roofs and bioswales in targeted areas. This helps manage rainwater on-site, reducing the risk of overflows and the contamination of rivers and waterways. Similarly, London has embraced green infrastructure as part of its strategy for dealing with climate change. The Thames Barrier and the Thames Tideway Tunnel are critical to managing the risks of flooding, but the addition of rain gardens and green walls throughout the city further enhances London's ability to cope with extreme weather. Looking toward the future, wastewater treatment will likely evolve to integrate advanced molecular techniques, such as nanotechnology and bioengineering, to improve treatment processes. Research is underway to explore how nanomaterials can be used to remove toxic substances, pharmaceuticals, and other emerging contaminants from wastewater. These innovations have the potential to provide even cleaner, more efficient wastewater treatment processes, enabling cities to purify water on a molecular level. As we stand at the crossroads of innovation and sustainability, it's clear that the future of sanitation lies in the integration of technology, resource recovery, and environmental protection. Joseph Bazalgette's legacy of creating a comprehensive, sustainable sewage system in Victorian London laid the foundation for modern urban infrastructure, and today's technologies are building upon that foundation. The global sanitation crisis remains a pressing issue, but with innovations in wastewater treatment, smart infrastructure, and green solutions, cities around the world are moving toward a more sustainable and resilient future. Joseph Bazalgette's work showed us that infrastructure is not just about solving immediate problems, but about creating a system that can adapt and thrive in the face of future challenges. His vision of a modern sewage system was just the beginning, and today's engineers, scientists, and urban planners are building on his legacy to create healthier, more sustainable cities for generations to come. Good night, and thank you for joining us on this incredible journey through the history and future of sanitation systems and public health. We've seen how innovative technologies and sustainable solutions are shaping the cities of the future. Don't forget to subscribe, like the video, and leave a comment below on where you're watching from. We look forward to continuing this journey with you. Welcome to our channel, where we dive into the untold stories of history, exploring the struggles and survival stories from the past. Tonight, we're diving into one of the most challenging times in London's history, The spread of deadly diseases during the Victorian era. At a time when sanitation was inadequate and medical knowledge was still in its infancy, London was plagued by terrifying diseases like cholera, typhus, and tuberculosis. These diseases would often spread rapidly through the crowded, unsanitary slums, and the people living there had to find ways to survive in the face of these overwhelming threats. We'll explore how these deadly diseases spread, the horrifying conditions that allowed them to thrive, and how people managed to survive in such harsh environments. Before we jump in, make sure to subscribe to our channel and like this video to help us continue bringing you these fascinating stories. Let us know in the comments where you're watching this video from. We love hearing from our viewers all over the world. Now, let's begin our story. Victorian London, a city bustling with life, was a city on the brink of disaster. The rapid expansion during the Industrial Revolution brought people from the countryside to the city in droves, desperate for work in factories, coal mines, and other industrial hubs. By the mid-1800s, London's population had swelled to over 2 million, and the city was struggling to keep up with the demand for housing and infrastructure. With this explosive urbanization, living conditions in the poorer parts of London became horrific. People were crammed into overcrowded slums, with multiple families often sharing small, poorly ventilated spaces. Sanitation was almost non-existent, with waste and sewage flowing openly in the streets, mixing with the water supply. It was in this grim environment that deadly diseases began to thrive, and they spread quickly among the population. One of the most notorious diseases of the time was cholera. This waterborne disease, caused by the bacteria Vibrio cholerae, spread through contaminated drinking water, and it was one of the leading causes of death in London during the Victorian era. Cholera outbreaks were terrifyingly common, with waves of death sweeping through the city at regular intervals. It often began with a violent fever and diarrhea, followed by severe dehydration and eventual death if untreated. The first major cholera outbreak in London occurred in 1831, and by the 1850s, London had seen several devastating epidemics. The spread of cholera was directly linked to the lack of sanitation and the contamination of water sources. In the poorer neighborhoods, where the water supply was often shared by multiple households, the situation was even worse. People were drinking from contaminated wells or rivers, which were often polluted with raw sewage. Despite the fact that cholera was killing hundreds, even thousands of people at a time, medical professionals at the time had little understanding of how it spread. Most believed that diseases like cholera were caused by miasma, the idea that foul smells from rotting waste and filth in the air caused illness. This belief meant that efforts to combat the disease were focused on cleaning up the air, rather than addressing the real cause, contaminated water. As cholera swept through London, public panic ensued. Whole neighborhoods were ravaged by the disease, and bodies piled up in the streets as the death toll mounted. The healthcare system was unprepared to deal with such widespread outbreaks. Doctors were few and far between, and many had limited understanding of how to treat or prevent diseases. The working class was hit hardest, with many living in the most overcrowded and unsanitary conditions, where disease could spread unchecked. Despite the medical ignorance, there were those who fought back. One of the key figures in understanding the spread of cholera was a man named John Snow. In 1854, Snow, a doctor, noticed that a cholera outbreak in the Soho district of London was centered around a single water pump on Broad Street. He famously mapped out the locations of all the cholera cases and discovered that the majority of them had been drinking from that pump. His research and careful study led him to believe that the disease was spread through contaminated water, not the air. While his ideas were met with skepticism at the time, Snow's work laid the foundation for the understanding of germ theory and waterborne diseases. Although John Snow's discovery was groundbreaking, it wasn't until later that his findings led to substantial changes in public health practices. In the meantime, the cholera outbreaks continued, and the working poor were left to fight for their survival. For many, survival meant enduring the harshest conditions and doing whatever was necessary to protect their families. In the worst affected areas, people sought refuge in makeshift shelters, hoping to stay out of the path of the disease. Other deadly diseases also made their presence known during this time. Typhus, another disease associated with poor sanitation, was rampant in the overcrowded slums. Typhus is caused by a bacterium spread by lice and fleas, which thrived in the filthy conditions of the city. Like cholera, typhus spread quickly and took a terrible toll on London's poor population. It often began with fever, severe headaches, and body aches, and it was frequently fatal without treatment. The spread of typhus was also facilitated by the close living quarters of the working poor. Families living in squalid conditions, with poor ventilation and no access to clean water, were constantly exposed to the lice that carried the disease. Medical understanding of typhus was also limited at the time, and it wasn't until later that doctors made the connection between the disease and the lice that infested the dirty clothes and bedding of the poor. Typhus was so widespread in Victorian London that it was referred to as the quote, king of diseases due to the high mortality rate it caused among the lower classes. As the population grew and the city continued to expand, the spread of tuberculosis also became a major concern. This disease, which primarily affects the lungs, is caused by a bacterium called Mycobacterium tuberculosis. It was highly contagious, especially in crowded living conditions, and it thrived in the poor neighborhoods where people lived in close quarters with inadequate ventilation. Tuberculosis was particularly devastating to the working poor, who were already weakened by malnutrition and poor living conditions. The disease spread easily through the air when an infected person coughs or sneezes, and many people were infected without even realizing it until it was too late. Despite these overwhelming health crises, the residents of London did what they could to survive. Many families found comfort in community support, relying on each other for food, shelter, and care. The close-knit communities of the poor often became a lifeline, and people looked out for each other in times of crisis. Charitable organizations, such as the Salvation Army and local parish charities, also began to emerge during this time, providing food, shelter, and medical assistance to those most in need. But despite these efforts, survival was often a matter of luck, and many families lost loved ones to disease. The working poor were left to endure without the medical support and resources enjoyed by the wealthier classes. In the face of widespread suffering, public health reforms began to gain momentum toward the end of the 19th century. The most significant reform came in the form of improved sanitation and the gradual introduction of clean water systems and modern sewage infrastructure. The Great Stink of 1858, when the smell of raw sewage became unbearable in the heart of London, led to a renewed push for sanitation reform. The creation of a new sewage system, led by engineer Joseph Bazalgette, helped to reduce the incidence of cholera and other diseases linked to poor sanitation. Bazalgette's work is often credited with having saved thousands of lives by providing London with the infrastructure it desperately needed. By the time the 20th century dawned, disease control in London had improved, though many of the challenges faced by the poor remained. Public health systems were better equipped to handle epidemics, and advances in medicine led to more effective treatments. However, the legacy of the Victorian-era health crisis remained, and the struggle to provide equitable health care to all continued into the modern era. As we continue our exploration into the deadly diseases that ravaged Victorian London, it's essential to look at the specific outbreaks and how they shaped the scientific and public health advancements of the time. The Victorian era was marked by a series of devastating disease epidemics that took the lives of thousands of Londoners, especially among the working class. Cholera, typhus, and tuberculosis were the most infamous of these diseases, but they were not the only ones that contributed to the public health crisis in the city. Understanding how these diseases spread and the efforts to combat them gives us a clearer picture of how modern public health emerged from the chaos of Victorian London. The first major epidemic that we'll focus on is cholera, a disease that devastated London multiple times during the 19th century. The first outbreak of cholera in London occurred in 1831 with devastating effects. Cholera spread quickly and easily through contaminated water sources, often carried by sewage that found its way into the Thames River, the main source of drinking water for many of London's residents. At the time, there was no understanding of germs or how diseases spread. People believed that cholera, along with many other illnesses, was caused by bad air or miasma. This belief led to ineffective solutions, such as trying to clean the air by burning chemicals or using perfumes to mask foul smells. The second cholera epidemic in 1848 was especially deadly. By this point, London's population had continued to grow, and unsanitary conditions in the slums had worsened. The working-class districts were overcrowded, and sewage systems were primitive at best. This made it easy for cholera to spread rapidly. Whole neighborhoods were decimated, and the death toll reached thousands. But the people were still unaware of the true cause of the disease. It wasn't until John Snow, a pioneering physician, conducted his groundbreaking research during the 1854 cholera outbreak in the Soho district that the theory of waterborne diseases began to gain traction. Snow, who had been studying the pattern of cholera infections, noticed that most of the affected cases were centered around a single water pump on Broad Street. Through meticulous mapping, he proved that cholera was not caused by miasma, but by contaminated water. By persuading authorities to remove the pump's handle, he effectively ended the outbreak in that area. Though Snow's discoveries were not fully accepted by his contemporaries, his work was instrumental in shaping future public health policies. His findings helped to lay the groundwork for the eventual acceptance of germ theory in the late 19th century and were a turning point in public health history. Following the cholera outbreak of 1854, some changes began to take shape. Sanitation reforms were slow but started to take hold. The city began to take more seriously the need for cleaner water sources, proper sewage systems, and better waste disposal. But the death tolls from cholera continued to rise in the years following Snow's discovery, due in large part to lack of immediate infrastructure and the overwhelming urban population growth. Another devastating disease that struck London during this period was typhus. Typhus, caused by a bacterium spread by lice, was another killer that thrived in the overcrowded, unsanitary conditions of the slums. Typhus was often called the king of diseases due to its ability to wipe out entire communities. The disease was particularly dangerous because it spread quickly in areas where people were living in close quarters and lacked access to clean clothes or bedding. Typhus often accompanied cholera outbreaks, compounding the suffering of the poor. Unlike cholera, however, typhus was more directly linked to personal hygiene and filth. People who lived in filthy, damp conditions, with little access to fresh water or the ability to keep their clothing clean, were at the highest risk. With limited medical understanding, there were few effective treatments for typhus, and many victims simply had to endure the disease until it either ran its course or ended fatally. The Great Irish Famine of the 1840s, which sent a wave of Irish immigrants to London, exacerbated the typhus crisis. The influx of impoverished immigrants who were forced to live in the already overcrowded slums contributed to a further spread of the disease. By the time it reached its peak in London, typhus had become an unstoppable force, leading to thousands of deaths in the slums. While typhus was eventually recognized as being spread by lice, it wasn't until the late 19th century that modern medical understanding would lead to the development of more effective treatments and better preventative measures. In the face of these disease outbreaks, London's medical establishment began to take action. In 1854, in response to the devastation caused by the cholera epidemic, the General Board of Health was established to address public health issues. The board was tasked with investigating the causes of diseases and making recommendations for improving living conditions. Unfortunately, the board faced significant opposition from politicians and other influential figures who were resistant to change, and it was disbanded in 1858 after the passing of the Public Health Act. Nevertheless, the introduction of government-sponsored health reform marked a turning point in the Victorian response to disease. Though the initial reforms were slow, they eventually paved the way for more substantial efforts. The most notable of these efforts came in 1858, with the passing of the Public Health Act, which called for a large-scale overhaul of London's infrastructure. The new system of modern sewers, developed by Joseph Bazalgette, was designed to take sewage out of the streets and carry it to a treatment facility, where it could be properly disposed of. This act led to the creation of one of the most significant public works projects of the Victorian era, which would not only reduce cholera outbreaks but also greatly improve overall public health. Meanwhile, the typhus problem began to subside as the public began to understand more about hygiene and the connection between cleanliness and disease prevention. Public health campaigns started to teach the poor about personal hygiene and the importance of keeping their homes clean. and this knowledge helped to curb the spread of lice and other parasites. As the 19th century drew to a close, tuberculosis became another major concern in London. Known as the White Plague, tuberculosis was a lung disease that spread through the air when an infected person coughed or sneezed. Unlike cholera or typhus, tuberculosis could take months or even years to develop, and it often struck at the working poor who lived in the cramped, poorly ventilated conditions of London's slums. Tuberculosis became one of the leading causes of death in London by the end of the 19th century, and the medical establishment struggled to find effective treatments. It wasn't until the 20th century that the germ theory gained widespread acceptance, and scientists began to understand how tuberculosis spread. The development of treatments, such as the BCG vaccine and later antibiotics, would eventually help to curb the impact of tuberculosis in industrialized nations. Still, during the Victorian era, many of those afflicted with the disease simply had to endure, living in fear of the slow and painful death it often brought. The diseases of the Victorian era were a brutal reminder of the harsh realities faced by the poor in London. Cholera, typhus, and tuberculosis were not just medical challenges. They were reflections of the profound inequality that existed in the city. While the wealthy lived in comfort, the working poor endured the horrors of disease, overcrowded housing, and poor sanitation. And yet, despite these overwhelming challenges, the people of Victorian London found ways to survive. Through the work of brave physicians like John Snow, Joseph Bazalgette, and countless others, the city slowly began to implement reforms that would lead to a healthier future. Though the struggle against disease in Victorian London was far from over, it set the stage for the improvements in public health that would follow in the 20th century. As we continue our journey through the deadly diseases of Victorian London, it's essential to understand the resilience of the people who lived through these difficult times. The poor and working-class residents, who lived in the slums and crowded neighborhoods of London, faced incredible challenges not only from disease, but from the harsh social and economic realities that shaped their lives. While the upper classes had access to better living conditions, medical care, and a greater level of comfort, the working poor often had to rely on community solidarity, survival skills, and a strong will to endure. Despite the overwhelming threat of diseases like cholera, typhus, and tuberculosis, many people in these poorer communities managed to survive, often through sheer determination and resourcefulness. The survival of these communities wasn't simply a matter of luck. It was shaped by their ability to adapt and take care of one another in the face of seemingly insurmountable odds. One of the most striking examples of survival came during the cholera outbreaks of the 1830s and 1840s. When cholera first struck London in 1831, the poor had little to no access to the public health systems that would eventually emerge. As we discussed in earlier parts of the story, the unsanitary living conditions in the slums, combined with the lack of proper sewage systems and clean water, made it almost impossible for people to avoid contamination. Yet despite the fear and panic that cholera caused, there were stories of communities that managed to survive and protect each other through self-help and community action. In the East End of London, one of the areas hardest hit by cholera, residents came together to create informal systems of care. With the absence of adequate medical care, many working-class people had to rely on herbal remedies, home treatments, and the advice of local midwives or folk healers. Charitable organizations also played a crucial role in providing aid to the victims. Churches and parish councils often served as gathering points where people could receive food, clean water, and sometimes even medical attention, although the latter was far from sufficient. In areas like Spitalfields, where the Irish immigrants had settled in large numbers, people would come together to create makeshift hospitals in their homes or in community centers. These spaces were often overcrowded and lacked proper medical equipment, but they provided a sense of solidarity during times of crisis. Community leaders, often volunteers who had little to no formal medical training, would offer their services as best they could, administering simple remedies, offering water to the sick, and helping to care for children who had been left orphaned by the disease. While these efforts didn't stop cholera from claiming the lives of many, they were a testament to the strength of community in times of crisis. The people of Victorian London, especially the working poor, didn't simply wait for help to arrive. They created their own networks of support, taking care of each other when the larger society seemed indifferent to their suffering. These survival networks would form the foundation of much of the social action that followed in the wake of the cholera outbreaks, and they contributed to the eventual public health reforms that sought to eliminate the conditions that allowed such diseases to spread. Typhus, which we discussed in earlier parts of the story, was another disease that wreaked havoc on London's poor. The disease, spread by lice and fleas, was particularly prevalent in the overcrowded and unsanitary conditions of the slums. Families living in tiny, poorly ventilated rooms were particularly vulnerable to typhus, which would spread rapidly through communities that lacked basic hygiene facilities. But, again, survival depended on both individual and collective action. Many working-class families had to cobble together whatever resources they had to survive the worst of these epidemics. Typhus often came hand in hand with poverty and malnutrition, so those who were already weakened by their environment were more likely to succumb to the disease. The poor, however, developed ingenious ways of fighting back. In the absence of any formal medical help, they relied heavily on herbal treatments and home remedies passed down through generations. Garlic, ginger, and peppermint were common herbs used to help treat the symptoms of typhus, though they had little effect on the disease itself. But what these remedies lacked in medical efficacy, they made up for in the comfort they provided. More importantly, self-reliance and community care remained the cornerstone of survival for the working poor. Neighbors helped one another by bringing food and water to the sick, watching over their children, and helping to bury the dead when families were too weak to do so themselves. These collective survival strategies helped the poor endure some of the worst outbreaks of typhus, and in the process, they developed a culture of mutual aid that would continue to define the working-class experience in London for years to come. The third major disease of the time, tuberculosis, also known as consumption, was a constant presence in the lives of London's poor. Tuberculosis spread primarily through the air when an infected person coughed or sneezed, and it thrived in the overcrowded, poorly ventilated homes where the working-class people lived. Tuberculosis often took a long time to develop, and it was a slow, painful disease. As with cholera and typhus, the poor suffered the most, with children and young adults often bearing the brunt of the disease. But despite the slow pace of medical progress in the Victorian era, people did survive tuberculosis, and many lived with it for years before succumbing to its final stages. Those who had the means could seek medical care, but the overwhelming majority of Londoners lived without access to doctors or hospitals. Instead, they turned to traditional treatments, often herbal and natural remedies, as well as a growing understanding of the importance of fresh air and rest. The belief that the disease could be slowed or halted by moving to the countryside, where the air was fresher and the environment less polluted, became widespread. For those who couldn't afford to leave the city, the best they could do was to make their homes as clean and well-ventilated as possible, despite the often oppressive conditions in which they lived. Tuberculosis hospitals began to emerge, but they were limited in number and often only accessible to the wealthier classes. It wasn't until the late 19th and early 20th centuries that modern treatments for tuberculosis, including sanatoriums and anti-tuberculosis medications, began to offer hope for those afflicted by the disease. The survival stories of the Victorian poor weren't just about enduring disease. They were also about surviving the incredibly harsh living conditions that helped spread these diseases in the first place. Public health reforms in the Victorian era, although slow and often resisted by the wealthy, were eventually put in place to improve the living conditions of the poor. Joseph Bazalgette's sewer system, which was completed in the 1860s, was one of the most significant public health projects in the history of London. The London sewage system helped reduce the spread of cholera and other diseases by diverting waste away from the drinking water supply and providing more efficient waste management for the city's growing population. Alongside the development of better sewage systems, improvements in sanitation and clean water supply began to take shape in the late 19th century. Public health campaigns promoted the importance of cleanliness and personal hygiene, leading to a gradual improvement in living conditions for the poor. By the turn of the 20th century, the city's public health infrastructure had dramatically improved, although it would still take many years before the working-class neighborhoods of London were completely free of the diseases that had once been rampant. The survival of the poor during these terrible outbreaks of disease was nothing short of miraculous. Despite overwhelming odds, they managed to endure the worst of the Victorian health crises. Their resilience, resourcefulness, and reliance on community networks allowed them to survive in the face of unimaginable suffering. The medical discoveries and public health reforms that followed the epidemics were crucial in shaping the future of London and eventually led to improved conditions for the working class. Yet, it's the stories of survival from the most vulnerable members of society, the ones who had the least access to medical care and the fewest resources, that stand as a testament to the strength of the human spirit. As we continue our exploration of the deadly diseases that plagued Victorian London, it's essential to focus on the scientific advancements and public health reforms that emerged in response to these devastating outbreaks. These innovations and reforms not only shaped the course of medical history, but also contributed to the eventual improvements in the living conditions of the poor. The struggle to contain diseases like cholera, typhus, and tuberculosis was long and difficult, but the advancements that came out of this period marked a turning point in the fight against infectious diseases. The scientific advancements that began in the Victorian era laid the groundwork for modern public health systems, and these efforts would eventually lead to the dramatic reduction in deaths caused by these diseases. One of the most significant breakthroughs came with the work of John Snow, a pioneering physician whose studies of cholera helped establish the foundation of modern epidemiology. In 1854, during a cholera outbreak in Soho, London, Snow conducted groundbreaking research that would eventually prove that cholera was spread by contaminated water, not by miasma as was widely believed at the time. Snow mapped out the locations of cholera cases and found a clear pattern linking the disease to a single water pump on Broad Street. By convincing local authorities to remove the handle of the pump, Snow effectively halted the outbreak. His discovery was revolutionary because it demonstrated the importance of clean water in preventing the spread of disease. Although Snow's ideas were met with resistance at the time, his work laid the foundation for the development of germ theory and the modern understanding of disease transmission. Snow's research eventually contributed to the acceptance of germ theory, which would revolutionize medical science and public health. Before the advent of germ theory, diseases were often attributed to bad air, foul smells, or imbalances in the body's humors. However, after Snow's findings, the understanding that specific microorganisms cause diseases became widely accepted, leading to the development of vaccines, antibiotics, and better sanitation practices. Snow's work also helped to pave the way for future medical breakthroughs, including the development of the germ theory of infection by Louis Pasteur and the discovery of antiseptics by Joseph Lister. While scientific breakthroughs like Snow's were crucial in the fight against disease, they alone were not enough to end the devastating outbreaks of the Victorian era. Significant public health reforms were also needed to address the unsanitary conditions that allowed diseases to spread so easily in London. One of the first major steps in this direction came with the passing of the Public Health Act of 1848. This act was a response to the ongoing cholera outbreaks and the general squalor in the city's slums. It created the General Board of Health, which was tasked with investigating the causes of diseases and recommending measures to improve public health. While the board had limited power, its creation marked the beginning of the government's involvement in regulating public health. One of the most important aspects of the Public Health Act was the push for clean water and proper sanitation in London's poorest neighborhoods. These areas, where disease was most rampant, had no proper sewage systems, and waste was often disposed of in the streets or in open gutters. In many cases, drinking water was contaminated by raw sewage, making it a breeding ground for cholera and other waterborne diseases. The government's response was to create more stringent regulations regarding the quality of drinking water and to improve the infrastructure for waste disposal. The sewer system that was developed in response to these needs was one of the largest public works projects in Victorian London. The man responsible for this monumental project was Joseph Bazalgette, a civil engineer whose work would have a lasting impact on the city's public health. Bazalgette's design for London's modern sewer system was groundbreaking. His plan included a series of large, underground pipes that would carry sewage away from residential areas and into the Thames River. While this system didn't completely eliminate the problem of polluted water, it was a significant improvement and helped to drastically reduce the spread of diseases like cholera. Bazalgette's system was not only a triumph of engineering, but also an essential public health reform. It was completed in 1865, and within a decade, cholera deaths in London had dramatically decreased. While the sewer system alone did not eradicate disease, it provided the foundation for the city's growing sanitation infrastructure, and its success was a key factor in the eventual control of cholera outbreaks in London. Another important public health reform in Victorian London was the focus on housing conditions. The rapid urbanization of London during the Industrial Revolution had led to the creation of sprawling slums where overcrowded and unsanitary living conditions were the norm. The poor lived in cramped, poorly ventilated rooms, with little access to fresh air, clean water, or proper waste disposal. These conditions were a perfect breeding ground for diseases like typhus, cholera, and tuberculosis. The government began to recognize that the poor housing conditions were contributing to the spread of disease. In the mid-19th century, several pieces of legislation were passed to improve the quality of housing for the working class. The Artisans and Laborers' Dwellings Improvement Act of 1875 was one of the most significant pieces of legislation aimed at improving housing in London's slums. It allowed local authorities to demolish dilapidated buildings and replace them with new, better quality homes for the poor. While this reform was not perfect, it marked a significant shift in public attitudes toward housing and health. The idea that good housing was a basic human right and that it could help prevent the spread of disease began to take hold. Over time, the development of public housing and improved urban planning would continue to shape the city's growth and its ability to combat the diseases that had once been a scourge of London's poor. In addition to these reforms, the Victorian era also saw the rise of public health campaigns that focused on hygiene, cleanliness, and disease prevention. Public health campaigns were often led by charitable organizations, philanthropists, and medical professionals who sought to educate the poor about the importance of personal hygiene and sanitation. These campaigns included the distribution of pamphlets, the establishment of health education programs, and the promotion of cleanliness in public spaces. As part of these campaigns, the Royal Sanitary Commission was created in 1850 to investigate the living conditions of London's poor. The Commission's report, which was published in 1851, highlighted the squalid conditions in the city's slums and called for improvements in public health and sanitation. The Commission's findings played a crucial role in convincing the government to take more active steps in addressing the public health crisis. By the end of the Victorian era, London had made significant strides in improving public health, but it was still a city grappling with inequality and disease. The sewer system, improvements in housing, and the rise of hygiene education were important steps forward. But the fight against disease was far from over. The impact of the Victorian public health reforms set the stage for the future development of modern public health systems and helped to reduce the spread of infectious diseases in the long run. However, these advances did not come easily. The battle to improve sanitation and combat diseases like cholera, typhus, and tuberculosis required immense public pressure, scientific research, and the tireless efforts of advocates who pushed for change. The people of Victorian London, especially the poor, had to endure immense suffering before these reforms took hold. But through resilience and community action, the working class was able to survive and lay the foundation for a healthier, more equitable society. As we continue our exploration of the Victorian health crisis, it's important to understand the long-term effects of the public health reforms that were implemented in response to the deadly diseases that plagued London. The reforms that began to take shape in the mid-19th century had a profound impact on the development of modern medicine, urban planning, and public health systems in the 20th century. These early efforts in combating disease not only transformed the living conditions of the working poor, but also laid the groundwork for a global health revolution that would eventually change the way we live today. While the immediate effects of the reforms were felt in London, they would also have a ripple effect that influenced public health practices around the world. The Victorian public health movement, although often limited in scope and facing resistance from various quarters, represented a pivotal moment in the development of the modern state's role in managing public health. The efforts to combat cholera, typhus, tuberculosis, and other deadly diseases directly contributed to the creation of health infrastructures and a new approach to sanitation, disease prevention, and healthcare access that would have lasting impacts for generations to come. One of the most significant long-term effects of the Victorian public health reforms was the advancement of medical science. The germ theory of disease, which gained acceptance in the second half of the 19th century, was the result of the groundwork laid by figures like John Snow and Louis Pasteur. Prior to the acceptance of germ theory, diseases were widely believed to be caused by bad air or imbalance in the body's humors. The understanding that specific microorganisms caused diseases was a revolutionary breakthrough in medical science. Snow's research on cholera, which showed that the disease was spread through contaminated water, was a crucial turning point in the development of epidemiology. At the same time, Pasteur's experiments in bacteriology demonstrated the role of microbes in causing infections, leading to the development of vaccines and antiseptics. As the scientific understanding of diseases advanced, so did the development of medical treatments. The germ theory of disease helped to shift the focus of medicine from treating symptoms to targeting the underlying causes of illness. In the decades following the Victorian era, this would lead to the development of vaccines, antibiotics, and antiseptic surgery, all of which would dramatically reduce mortality rates from infectious diseases. The development of the smallpox vaccine and the discovery of penicillin in the early 20th century were direct outcomes of the scientific advances that began in the Victorian period. In addition to the scientific advancements, the public health reforms of the Victorian era contributed to the rise of modern medical institutions. The establishment of hospitals, particularly those focused on infectious diseases, helped to provide care for the growing population in London and across the world. The founding of institutions like the London School of Hygiene and Tropical Medicine in 1899 and the Royal Sanitary Institute in 1857 marked important milestones in the development of public health education. These institutions trained a new generation of doctors, nurses, and health workers who would go on to play key roles in improving public health across the globe. The public health infrastructure that emerged in Victorian London also had a significant impact on urban planning. The rapid industrialization of London and the associated overcrowding in the city's slums had created a perfect storm for disease. The lack of sanitation, poor housing conditions, and inadequate water supply were the primary contributors to the spread of diseases like cholera, typhus, and tuberculosis. The Victorian response to these problems was to rethink the design and layout of cities to ensure that they were cleaner, healthier, and better equipped to handle a rapidly growing population. The most significant urban planning reform was the creation of a modern sewer system. The sewer system designed by Joseph Bazalgette was a groundbreaking project that fundamentally changed the city's infrastructure. By constructing a network of large underground pipes to carry sewage away from residential areas and into the Thames River, Bazalgette helped to eliminate the most immediate source of cholera and other waterborne diseases. This sewer system became the backbone of modern sanitation in London and was a model for other cities around the world. Bazalgette's work demonstrated the importance of integrating public health into urban planning, and his legacy lives on in the design of cities today. Alongside the sewer system, public health reforms also called for the development of green spaces, better housing, and improved public sanitation. The establishment of public parks and the creation of open spaces in urban areas were a direct result of the Victorian focus on improving living conditions. These green spaces provided residents with access to fresh air and recreation, and they also helped to reduce the impact of pollution in rapidly industrializing areas. At the same time, public health reforms led to the creation of better quality housing for the poor, with better ventilation, sanitation, and access to light. These reforms slowly improved the quality of life for London's working-class population, and they provided a blueprint for future urban development. By the late Victorian era, the city's public health system had significantly improved, but the long-term impact of these reforms extended far beyond the City of London. The success of these early public health measures became a model for other industrialized nations, particularly as cities around the world grappled with similar health crises. The growing recognition that sanitation, clean water, and disease prevention were key to public health led to the spread of these reforms to other major cities in Europe, the United States, and beyond. In the United States, the influence of Victorian public health reforms was particularly evident in the development of municipal sanitation systems. New York City, for example, implemented large-scale sewer systems and water filtration systems in the early 20th century, modeled after the successful initiatives in London. Similarly, public health campaigns focused on cleanliness and hygiene spread across the globe. The World Health Organization, WHO, founded in 1948, built on these early efforts by focusing on the importance of clean water, nutrition, and disease prevention in creating a healthier world. However, despite these impressive gains, health inequality continued to persist throughout the world. While the public health reforms of the Victorian era laid the foundation for the modern welfare state, they were not a complete solution to the problems of urbanization, poverty, and disease. The working class, despite improvements in sanitation and housing, continued to face challenges related to poor nutrition, overcrowded living conditions, and limited access to healthcare. These ongoing issues highlighted the need for continued reform in the 20th century as new diseases and health challenges emerged. The fight against disease in Victorian London was a long and painful battle, but it ultimately led to the birth of modern public health systems. The scientific breakthroughs of figures like John Snow, Louis Pasteur, and Joseph Bazalgette, along with the growing awareness of the need for sanitation and disease prevention, helped shape the trajectory of public health in the 20th century. The legacy of these reforms can be seen in the development of modern healthcare systems that continue to prioritize the control of infectious diseases, the importance of sanitation, and the promotion of health through education and infrastructure. The Victorian public health movement demonstrated the power of collective action, the importance of science and innovation, and the need for government intervention to create a healthier, safer society. While many challenges remain, the reforms of the Victorian era were a vital step toward creating a world where health was recognized as a right rather than a privilege. As we continue to explore the transformative public health journey that began in Victorian London, it's essential to examine how the public health reforms and scientific advancements made during the 19th century spread beyond the confines of the city and into global health initiatives. The reforms in sanitation, water supply, and disease prevention that began in London were not only revolutionary for the city, but also paved the way for the emergence of modern medicine and public health systems worldwide. The changes that occurred in Victorian London served as a blueprint for cities across the globe grappling with similar problems caused by industrialization, overcrowding, and disease. As cities worldwide grew, the insights gleaned from London's early public health efforts helped shape the trajectory of global public health movements throughout the 20th century. While much progress had been made, the 20th century also introduced new health challenges, many of which arose as a result of the very advancements in medicine and technology that were shaping the world. The global spread of public health reforms began in earnest in the latter half of the 19th century, particularly after the success of Joseph Bazalgette's sewer system in London. This system not only saved countless lives, but also became a model for cities worldwide. As urban populations grew, the spread of infectious diseases continued to be a pressing concern, and many cities began to invest in their own sewer systems and water filtration systems inspired by London's reforms. The idea that sanitation and clean water were essential to controlling the spread of diseases was a revolutionary concept at the time. As cities in the United States, Europe, and other parts of the world grew, cholera, typhoid, and other waterborne diseases remained a constant threat. The success of London's public health reforms provided a tangible solution to these threats, leading to the adoption of similar infrastructure projects in other cities. In New York City, for example, public health leaders began to implement modern sewage systems in the late 19th century, inspired by the successes of London's sewage reforms. The idea that waste removal and clean water were directly linked to public health spread to cities across the United States and Europe. Many cities began to invest heavily in clean water sources and improved waste management systems to reduce the spread of disease and improve the quality of life for their citizens. Simultaneously, scientific knowledge about the germ theory of disease began to spread rapidly. In 1876, Louis Pasteur and Robert Koch helped prove that specific microorganisms were responsible for various diseases, including tuberculosis and cholera. This scientific breakthrough revolutionized the medical community's understanding of how diseases spread and led to vaccines antiseptic techniques, and other treatments that would change the course of medicine forever. The 20th century witnessed a number of new health challenges, many of which were directly linked to the rapid advances in industrialization, technology, and urbanization. While public health reforms continued to make progress, new diseases, influenza, HIV/AIDS, and antibiotic-resistant bacteria presented new threats that had to be addressed. The global nature of modern travel allowed diseases to spread more quickly than ever before, and the increasing reliance on antibiotics and vaccines raised concerns about overuse and the potential development of drug-resistant infections. In the early 20th century, one of the greatest successes of modern medicine came with the eradication of smallpox, one of the deadliest diseases known to humankind. Smallpox had plagued humanity for thousands of years, killing millions of people. However, after the development of a vaccine by Edward Jenner in 1796 and its widespread use during the 20th century, the World Health Organization, WHO, launched a global smallpox eradication campaign in 1967. This campaign, which focused on vaccinating the global population and isolating outbreaks, was declared a success in 1980 when smallpox was officially eradicated. This global victory in the fight against smallpox demonstrated the power of vaccination and global cooperation in the battle against infectious diseases. It also set the stage for future public health initiatives, including the global fight against polio, malaria, and HIV/AIDS, which became major challenges in the latter half of the 20th century. However, as public health systems evolved and more diseases were brought under control, new challenges arose. One of the most pressing issues in the 20th century was the rise of chronic diseases, many of which are directly linked to modern lifestyle choices, such as diet, exercise, and tobacco use. The rise of cardiovascular diseases, diabetes, and cancer in the second half of the century shifted the focus of public health from infectious diseases to lifestyle-related diseases. As the world became more industrialized, many of these chronic conditions became prevalent in developed countries and began to emerge in developing nations as well. The global rise of obesity, particularly in developed nations, has been one of the most significant public health issues of the late 20th and early 21st centuries. The widespread consumption of processed foods, sugary beverages, and high-calorie diets, combined with a more sedentary lifestyle, has led to a dramatic increase in obesity rates, particularly among children. Obesity, in turn, is linked to an increase in diabetes, heart disease, and other chronic illnesses. These trends have prompted governments and public health organizations to focus on preventing lifestyle-related diseases, encouraging people to adopt healthier diets and more active lifestyles. The challenge of combating chronic diseases has also highlighted the growing importance of mental health. As the world has become more fast-paced and stressful, there has been a rise in mental health conditions such as depression, anxiety, and stress-related disorders. In response, public health efforts have begun to place a greater emphasis on mental well-being, advocating for better access to mental health services and promoting mental health awareness. While the 20th century introduced new public health challenges, it also witnessed the continued evolution of the global health landscape. The creation of the World Health Organization, WHO, in 1948 marked a major step forward in international cooperation to address global health issues. The WHO's work in promoting vaccination, disease prevention, and health education helped to reduce the burden of infectious diseases worldwide. The organization also became a leader in addressing health inequities, particularly in low-income countries, by providing technical assistance, funding, and expertise. The global spread of infectious diseases, including the HIV/AIDS epidemic that began in the 1980s, demonstrated the interconnectedness of the world's population and the importance of international collaboration in addressing global health threats. The rise of antiretroviral therapies, ART, for HIV/AIDS, along with awareness campaigns and prevention efforts, has helped to reduce the global impact of HIV/AIDS, though the disease remains a significant health challenge in many parts of the world. The rise of global travel, the interconnectedness of the world's population, and the increasing migration patterns of people have all contributed to the rapid spread of infectious diseases such as influenza, SARS, Zika, and, more recently, COVID-19. The COVID-19 pandemic highlighted the ongoing challenges in controlling diseases in an increasingly globalized world. The pandemic demonstrated the vulnerabilities of global public health systems, but also underscored the importance of cooperation and advances in science, such as the rapid development of vaccines to combat the virus. In summary, the public health reforms of the Victorian era, though initially focused on diseases like cholera, typhus, and tuberculosis, set in motion a series of scientific advancements and public health practices that have shaped the way we approach health today. The progress made in sanitation, disease prevention, and medical science during the Victorian period laid the foundation for the modern health systems that have transformed the global health landscape. While infectious diseases were the focus of the 19th century, the 20th century saw the rise of new challenges, including the growing burden of chronic diseases, mental health issues, and the ongoing need to address global health inequities. The future of public health will undoubtedly involve continuing to combat these challenges while maintaining the global cooperation and scientific advancements that have shaped the trajectory of health over the last century. As we move further into the 20th and 21st centuries, the influence of the public health reforms that began in Victorian London continued to shape the global health landscape, especially in developing countries. While much of the progress in public health was initially seen in industrialized nations like Britain, the impact of those reforms eventually spread to colonial territories and later to newly independent countries. The progress in sanitation, disease prevention, and the establishment of healthcare systems in these areas was vital in shaping the global health systems we see today. In many ways, the Victorian public health reforms, particularly the efforts to combat cholera, typhus, and tuberculosis through improved sanitation and clean water systems, provided a blueprint for global health initiatives. The challenges faced by developing countries in the 20th century were often similar to those encountered in Victorian London. However, the scale of these problems was often far greater due to overpopulation, poverty, and political instability in many regions of the world. As colonial powers expanded in the 19th and early 20th centuries, healthcare systems were often established to protect the interests of colonizers rather than the local populations. In many cases, colonial health systems were designed to control the spread of disease among European settlers rather than to provide adequate care for the indigenous people. Health disparities between colonizers and the colonized were stark, with the local populations often suffering from poor nutrition, lack of clean water, and poor living conditions. After World War II and the subsequent decolonization period, many newly independent countries in Africa, Asia, and Latin America were faced with the task of building national health systems that could meet the needs of their poor and often rural populations. Public health reforms became a key component of the development agendas of many newly independent nations. These countries, like India, China, and Brazil, recognized that improving sanitation, nutrition, and disease prevention were critical to their social and economic development. One of the key achievements of public health in the mid-20th century was the eradication of smallpox. The global smallpox eradication campaign, led by the World Health Organization, WHO, was an extraordinary success. The campaign involved mass vaccination programs, surveillance systems, and targeted interventions in remote regions, where smallpox was still active. By 1980, smallpox was officially declared eradicated, marking a major milestone in global public health efforts. The success of this campaign proved that global cooperation and the application of scientific advancements could lead to the eradication of an infectious disease, which had once been a major global killer. The smallpox eradication program was particularly important for developing countries, where the disease was still prevalent and disproportionately affected the poor. The success of smallpox eradication served as a model for future global health initiatives, including efforts to combat polio, malaria, and measles. These campaigns used similar strategies of vaccination, surveillance, and education, and they aimed to eliminate preventable diseases in the poorest regions of the world. Another significant public health reform that affected developing countries was the promotion of sanitation and clean water. The WHO's efforts to provide clean water and improve sanitation in low-income countries became a central focus of its mission in the 1960s and beyond. Many developing countries, particularly those in sub-Saharan Africa and South Asia, faced severe challenges related to dirty water and poor sanitation, which contributed to the spread of diseases like cholera, dysentery, and typhoid. These diseases were particularly dangerous for children and could be prevented with access to clean water and proper sanitation infrastructure. The Water and Sanitation Program, WSP, launched by the WHO and other international organizations in the 1970s, was instrumental in addressing these issues. The program focused on providing low-cost solutions for clean water and sanitation in rural areas, where access to public health infrastructure was often limited. Simple interventions, such as hand-washing campaigns, the promotion of latrines, and the distribution of oral rehydration salts, ORS, for treating dehydration from diarrhea, led to significant reductions in mortality rates from waterborne diseases. These programs also help to improve public awareness about hygiene and disease prevention, empowering local communities to take control of their health. As global awareness of the importance of sanitation and water grew, international organizations such as the United Nations and the World Bank began to invest more heavily in health infrastructure in developing countries. These investments contributed to the improvement of health systems and the reduction of preventable diseases. In particular, the provision of clean drinking water and the construction of sanitation facilities were recognized as critical factors in the improvement of public health outcomes in the developing world. As the 20th century progressed, however, new challenges began to emerge. While infectious diseases were still a major threat, non-communicable diseases, NCDs, such as heart disease, diabetes, and cancer, began to increase in prevalence, particularly in urban areas. These diseases, often linked to lifestyle choices such as poor diet, lack of physical activity, and tobacco use, became more common in developing countries as they became more industrialized and westernized. The rise of these diseases posed a new public health challenge for countries that had once been focused on combating infectious diseases. In response, the World Health Organization and other international health bodies began to focus more on chronic diseases and health promotion. The global strategy on diet, physical activity, and health, adopted by the WHO in 2004, sought to address the rise of NCDs through public health campaigns promoting healthy eating, exercise, and smoking cessation. These initiatives aim to reduce the global burden of chronic diseases, particularly in developing countries, where the shift to processed foods, sugary drinks, and sedentary lifestyles was becoming more common. At the same time, global health initiatives began to focus on the mental health crisis. As cities grew and populations became more stressed by the pressures of modern life, mental health issues such as depression, anxiety, and stress-related disorders began to rise. These issues were particularly prevalent in urban areas, where people were often isolated, faced economic insecurity, and lived in stressful environments. In response, the WHO and national governments began to focus on mental health as a key component of public health, advocating for mental health awareness, access to care, and the reduction of stigma surrounding mental illness. The rise of globalization in the late 20th and early 21st centuries has had a profound impact on public health in developing countries. As travel and trade have increased, diseases that were once confined to specific regions have spread across borders more easily. The HIV/AIDS epidemic of the 1980s and 1990s is a prime example of how global interconnectedness can facilitate the spread of diseases. HIV, which originated in sub-Saharan Africa, spread rapidly to other parts of the world, particularly through global travel and the movement of populations. The epidemic highlighted the need for a global response to health crises, one that included prevention, treatment, and education. Similarly, the COVID-19 pandemic, which emerged in 2019, demonstrated the vulnerability of a globally interconnected world to infectious diseases. The pandemic affected every country on the planet, but its disproportionate impact on developing countries showed how health disparities remain a major challenge. The response to COVID-19 demonstrated the importance of global collaboration, with countries working together to develop vaccines and implement public health measures to curb the spread of the virus. Yet, it also underscored the need for equitable access to healthcare, particularly in low-income countries that lacked the resources to adequately respond to the crisis. As we look ahead to the future, the challenges of public health in developing countries will continue to evolve. The fight against infectious diseases like malaria, HIV/AIDS, and tuberculosis is far from over, but new threats are emerging, including non-communicable diseases, mental health disorders, and health impacts from climate change. The progress made in public health since the Victorian era has laid the foundation for continued advancements, but the work is far from finished. The lessons of the past, particularly the importance of sanitation, vaccination, and global collaboration, will continue to shape the fight for better health outcomes worldwide. As we step into the 21st century, the landscape of global public health is being reshaped by rapid advancements in technology and scientific innovation. From telemedicine and genomics to artificial intelligence, AI, and big data, technological innovations are providing new opportunities to improve healthcare access, diagnosis, treatment, and prevention. The progress made in public health since the Victorian era, spurred by scientific breakthroughs and public health reforms, has paved the way for these cutting-edge tools to revolutionize the way we approach global health challenges. However, as we continue to integrate these technologies, we must also consider the ethical, equitable, and global implications they bring. One of the most significant technological advancements in the last few decades is the rise of telemedicine, which is transforming the way healthcare is delivered. Telemedicine, the use of telecommunications and digital platforms to provide medical services remotely, has had a profound impact on improving access to care, particularly in remote and underserved areas. The development of telehealth services has made it possible for people in rural or isolated regions to consult with doctors, receive diagnoses, and even access prescriptions without the need for physical visits to a healthcare facility. In the context of developing countries, telemedicine has played a critical role in overcoming barriers to healthcare, such as limited healthcare infrastructure, shortages of medical professionals, and geographical distance. For example, in many regions of Africa and South Asia, where access to medical care is often limited to urban centers, telehealth platforms are bridging the gap by connecting local health workers with specialists in urban areas or even abroad. These platforms facilitate remote consultations, diagnostic services, and health monitoring, empowering healthcare providers to offer care to patients who would otherwise have no access to medical services. The global COVID-19 pandemic further accelerated the adoption of telemedicine, as many healthcare systems faced overwhelming pressure to provide care while minimizing the spread of the virus. Virtual consultations became the norm, not just for general health concerns, but also for mental health services, chronic disease management, and post-surgical care. As telemedicine continues to evolve, it has the potential to be integrated into health systems on a broader scale, improving healthcare delivery in the Global South, where health infrastructure remains underdeveloped. The promise of telemedicine lies not only in its ability to expand healthcare access, but also in its potential to improve efficiency and reduce healthcare costs. By providing remote consultations and follow-up care, telemedicine reduces the need for in-person visits, which can be costly and time-consuming. Furthermore, it can help alleviate pressure on overcrowded hospitals and clinics, especially in low-resource settings. Another game-changing development in modern medicine is the rise of genomics, the study of genes and their functions. Genomics has made it possible to analyze an individual's genetic makeup, identify genetic predispositions to diseases, and develop personalized treatments that are tailored to each individual's genetic profile. This rapidly evolving field is revolutionizing disease prevention, diagnosis, and treatment, particularly in the areas of cancer, genetic disorders, and infectious diseases. The impact of genomics on global health cannot be overstated. In developing countries, the ability to diagnose and treat genetic disorders early has the potential to significantly reduce the burden of diseases like sickle cell anemia, thalassemia, and cystic fibrosis, diseases that disproportionately affect certain populations. Genetic testing can identify individuals who are at risk for these conditions, allowing for early interventions and preventative measures that can save lives and reduce healthcare costs. Moreover, genomics is playing a pivotal role in the development of targeted therapies for diseases like cancer. Advances in precision medicine are allowing doctors to tailor treatments based on the specific genetic mutations present in a patient's tumor. This has resulted in more effective treatments for certain types of cancer, with fewer side effects compared to traditional treatments like chemotherapy. As the field of genomics continues to advance, it holds the potential to revolutionize cancer treatment on a global scale, offering hope for patients in both developed and developing countries. Genomics also plays a critical role in the fight against infectious diseases. By sequencing the genomes of pathogens like HIV, malaria, and tuberculosis, researchers can gain a deeper understanding of how these diseases evolve and develop resistance to treatments. Genomic surveillance is already being used to track outbreaks of diseases like Ebola, Zika, and COVID-19, providing real-time data on the genetic variations of the virus, which helps inform vaccine development and treatment strategies. The integration of artificial intelligence, AI, and big data into public health systems is another significant advancement that promises to revolutionize global healthcare. AI and big data can analyze vast amounts of health data to predict trends, identify potential outbreaks, and develop effective interventions. This technology can be used to track epidemics, predict disease outbreaks, and even provide real-time feedback on the effectiveness of public health interventions. In developing countries, where data on disease trends may be limited or incomplete, I can help fill the gaps by analyzing data from a variety of sources, such as hospital records, mobile health apps, and social media platforms. By identifying patterns in the spread of diseases, I can help healthcare providers predict where an outbreak is likely to occur next and allocate resources more efficiently. Additionally, AI-powered tools are being used to improve the accuracy of diagnostic tests, particularly in resource-limited settings where access to sophisticated medical equipment may be scarce. For example, in India, AI has been used to analyze medical images to help detect tuberculosis and diabetes more accurately. By utilizing AI algorithms to analyze chest X-rays and other medical scans, healthcare providers can quickly identify potential cases and begin treatment faster. This has been particularly beneficial in rural areas where access to trained radiologists may be limited. The use of big data also allows for the creation of more accurate epidemic models. By analyzing data on population movement, climate conditions, and disease transmission rates, public health authorities can develop better predictive models to forecast the potential spread of diseases like malaria or COVID-19. These models can help governments and health organizations prepare for future outbreaks and allocate resources accordingly. While the technological advancements discussed here offer exciting opportunities to improve global health, there are still significant challenges to overcome. One of the most pressing issues is the digital divide, the gap between those who have access to the latest technologies and those who do not. In many parts of the world, especially in low-income countries, access to the internet, mobile phones, and other digital tools is limited. This means that telemedicine, genomic testing, and AI-powered health tools may not be accessible to those who need them most. To ensure that technological advancements in public health benefit everyone, efforts must be made to expand digital infrastructure, train healthcare workers, and ensure equitable access to healthcare technologies. This includes investing in telecommunication networks, providing mobile health services to underserved regions, and ensuring that genetic testing and medical data are available at affordable prices. Another challenge is the ethical considerations associated with technologies like genomics and AI. As we begin to use genetic data to predict disease and develop personalized treatments, questions about privacy, data security, and genetic discrimination arise. Similarly, the use of AI in healthcare raises concerns about the potential for bias in algorithms, which could exacerbate existing health inequalities. It's essential that ethical guidelines and regulations are put in place to protect individuals' rights and ensure that these technologies are used for the greater good. Finally, there is the challenge of global health coordination. While technological innovations offer tremendous potential, they can only be effective if global health systems work together to implement them. This requires collaboration between governments, international organizations, and private sectors to ensure that new technologies are deployed in a way that benefits all populations, particularly those in developing countries. In conclusion, the rise of telemedicine, genomics, and AI is reshaping the future of global health. These technologies have the potential to improve healthcare delivery, diagnosis, and treatment in ways that were unimaginable just a few decades ago. However, as we move forward, it's important to address the challenges of access, equity, and ethics to ensure that the benefits of these advancements reach everyone, regardless of location or income. The legacy of Victorian public health reforms, which laid the groundwork for modern sanitation systems and medical advancements, continues to influence global health today. As we look to the future, the integration of technology with public health efforts will continue to shape the trajectory of global healthcare, offering new opportunities to combat infectious diseases, chronic conditions, and mental health disorders. Good night, and thank you for joining us of this fascinating journey through the history of public health. We've explored the role of technology in reshaping global health systems. Don't forget to subscribe, like the video, and leave a comment below on where you're watching from. We look forward to continuing this journey with you.